Hello everyone, myself Nidhi Shah, and I'm over here to present the paper. The paper title is Enhancing the Accessibility, a deep learning based image description for individuals with visual impairments. Going on with the presentation. Okay. As I said, myself Nidhi Shah, and the paper ID is 39725. The title of the paper is Enhancing the Accessibility Deep Learning Based Image Description for Individuals with Visual Impairments. I and Dr. Amit P. Ganatra together are the authors for the paper. The outline for the today's presentation is first introduction, system flow, proposed work, results, conclusion, and the references. Going on with the first, that is introduction. Over here for the paper, the research work is carried out using the RNN and CNN. The RNN, that is a recurrent neural network, is for the natural language descriptions, and convolution neural network and autoencoders are the feature extraction. Over here, we are trying to make a model, or we are trying to make, you can say, ease for the people with the visual impairment. Now, for making this thing, we have designed a model where the images are being given as an input, and finally an output in the form of audio is available. Now, going on with the further introduction, over here we create a comprehensive context-aware descriptions of the photographs, providing users with a better understanding of their surroundings. Demonstrating the accuracy and the reliability of the system on the wide range of photographs through the comprehensive testing. And finally, we promise to empower the visually impaired individuals and foster the digital diversity. The system flow, or the basic system flow, that how the model works. That is, first we will have an input to our system, the CNN, convolution network, autoencoder, is going to process and extract the feature. Then further, the output of the CNN is given as an input to the LSTM for the sentence. Finally, a sentence for an image is being generated. We call it as an image captioning. And finally, that captioning is being converted to speech. This is a basic flow. Now, how we are going to go on with the, further we are going to go on with the detailing of each of this module. Now for the system flow, as we have said, we are going to basically perform the fourth step. The first step is the image-based module, where we are going to use a CNN, a convolution, and a pooling layer to produce a feature vector for the input image. The ReLU layer follows each convolution layer, and the pooling layer strings the vector features before sending it to the next model. The fully connected network, CNN final layer, is not included in our model because we just need the vector features. Convolution pooling layer extract feature, while the fully linked network classify. Step number 2. Second, after we get you can say the feature vector, we go on with the language-based model receives the feature vector from the previous step. The encoded characteristic vector is decoded into a natural language captioning using the long short-term memory, that is we call as an LSTM technique, and the sophisticated RNN that stores a long data sequence. The LSTM memory cells preserves data for a longer time, and they have a start sequence and the end sequence, and they are using a token in a sentence, or we can call it as a caption sequence, and that is algorithm decide when to start and when to stop. Finally, the caption is created. The caption model emphasizes link between the things, colors, and actions. Converting the picture into an audio will be the last step. Now, the fourth step which you described are shortly being described in the presentation. Applying preprocessing step on image. In the input image, preprocessed pixel matrix is sent to an image-based model, and which creates a features using the CNN. Further, our output LSTM is used to decode the vector into a natural language caption, convert this caption into the speech. Okay, now going on with the first step, that is First, we are giving an input as an image. We encode it and we go with the compressed layer. Further, this compressed layer is being used directly for the training the images. And this training is being done on the images. And finally, this training will be used for testing part. So when we go with the compressed layer is being created by using the autoencoders. Step number 2. Now the train images, which we have got from the previous step, are given to our main model. And then that train images are being resized into 299 into 299 into 3. Further, after resizing, we give it for the feature extraction model, also called as an exception model. And finally, we apply a CNN and LSTM to this image. Now, CNN and LSTM are mentioned over here. The CNN and LSTM model. Now, we will understand the whole of this part in detail through the next slide. That is generating a caption and going on with the CNN part. So if we go with the CNN part, we have an image, we have a pre-processing, we have a feature extraction model, then feature vector of 2048 is being created. Then finally we go with the input layer, then we go with the dropout layer, and then we go with the dense layer. Parallelly, we have a caption generation where the text pre-processing part is being completed. We generate the vocabulary, we create a tokenizer for the each word. The next part, we go with the input layer. The input layer size is none, 32. The next layer is embedding layer. We have the size is none, 32 and 256. Further, a dropout layer. The size is none, 32 and 256. And then lastly, the dense layer, none and 256. Finally, both of these results are being combined and we built a model. That model is finally created and can be used further for testing our random images. The test images, further going on, we are going to resize those test images into 299 into 299 into 3. And that is again, feature is extracted through the exception model. And then we are going to predict using the previously trained model and generate a text. And then finally, we go with the text to speech. The results using this method these are the results. Okay. So over here, we have a results of CNN with attention map and also with using LSTM. And as we have done with the attention map and we are comparing the results with the LSTM, making sure that LSTM are having the better result with respect to the attention map. We are giving an input as an image, a random images, then model. We are using CNN plus LSTM and CNN plus attention map. Then further we go with the prediction. They say the dog is running through the snow. And over here, the white dog is running through the snow. The BLU is a parameter through which we have compared the, you can say the accuracy or you can say the relativeness of the statement, which we get as an output. BLU is a factor which will help us to confirm the output, or you can say to authorize our output. So these are the images and these are the results where we have got through the trained model. Okay, coming back to our PPT. The next conclusion, the proposed image captioning system used a CNN-based model to process image, extract features, and convert them into a natural language caption. It addresses a feature extraction and sequence creation issues, ensuring a precision and fluency. System also has a text-to-speech feature for visually challenged user. The BLE measure access performance, confirming alignment with human descriptions. The model uses a recurrent neural network, long short-term memory, and CNN for efficient and scalable captioning. The future work could include summarizing live video footage for visually impaired individuals. And these are the references. Thank you. Okay, so this was a overall uh, presentation of the work done by me and my co-author, Dr. Amit P. Ganatra. Thank you.